Now, a major difference today than what we did for today is an equation is going to have everything. What was missing from all the problems that we did? This was one that we had. This was one that we had. What was missing? The other number along with the equal sign, right? So today, we're going to have everything, and we're going to set everything up accordingly. It's going to follow very similar patterns as it did in writing the expression, but now they'll tell you equals something. Or what's another word for equals? 2 plus 2. What just is? Is. 2 plus 2 is 4. Would that work? Okay, so they'll come up with creative ways to say equals. Sometimes they'll just use equals. So if I tell you 8 more than a number equals 982. And we're going to take that phrase, that long phrase in writing, and put it into a more concise mathematical sentence, equation, if you will. Now, what part of this did we see yesterday and today? This first part right here. How do I show 8 more than a number? How do I show that? Yeah, right. Add. Give me the whole thing. Close. In order to know I have more than, I need to know what the original amount is first. Give me a variable. It says, does it say anything special? It says to use x to represent the variable. So, am I going to use 8 plus x or x plus 8 to show 8 more than a number? What do we do on the other side of your worksheet? What do we do there? We had some just like this. What do we do? Yes. X plus 8. And then all we're going to add today is equals 982 for today. We'll get to solving this, but not today. We'll get to figuring out what x is equal to, but not today. Today we're just going to set things up. Number 2, 9 less than a number equals 27. How am I going to show 9 less than a number equals 27? I'm going to show that. Whole thing. Okay. Oh. No, not that way. You get it backwards. Right. So x minus 9. 9 less than a number. And then finish it off. 27. There it is. Guided practice number 3. 0.5 times a number equals 300. Alexis. Zero 0.5 times a number equals what? What does it say? Okay. Now I want to just kind of refresh our memory here. When we were showing multiplication, and I said that we're going to start moving toward a certain way to show multiplication. Where is it? Come on. Okay? This was 1/4 times a number. Or 1/4 of n, of meant times. So if I'm using x to represent my variable, do I really want to show it this way? So give me a way I can make that just a little bit more concise. Instead of 0.5xx, yeah. Good. When I have a number like 0.5 jammed up right next to a variable, in this case x, without anything in between, it always means multiply. Without having to use x to show multiplication, I just take that number and I slam it up against the variable, put nothing in between. So 0.5x equals 300. And that's how we would do that one. Number 4, 1.25 times a number equals 103.75. Try that one. Number 4 is at the top of the page. Okay, a lot of people have come through this room thought they didn't like math. They actually did, and then they missed it. You're just sitting there eating lunch today, and you'll say, oh, how many sandwiches do I need to be full? Right? What variable would you use for sandwiches? S. But you could use whatever you want, except BLT. That'd be confusing. All right, how am I going to show multiplication here? Alexis. Very good. Just throwing that x. Now that x represents our what? Variable, not our multiplication. Because I could also make it this, or for Sierra, it doesn't matter, this is an S for Sierra. This doesn't matter, as long as I have a variable and it's slammed up right next to the number I'm multiplying it by, that's showing multiplication right there. See, then there's no confusion. If I use x to show multiplication, am I supposed to know if that's the x for multiplication or is that the variable x? So they get rid of it altogether. The other times maybe you've seen this to show multiplication. Why do you suppose they got rid of the dot to show multiplication as well once you start getting into algebraic thinking? Why do you suppose they took the dot away from us? Yeah, because sometimes people can confuse that dot with being a decimal. I mean, really, if you draw it just a little bit lower, you've seen some of your handwriting before. It looks like you write with your feet. Okay? So the easier we can make this on ourselves is just, just like this. This is how we're going to show multiplication. To show division, if I was dividing by it, I'd start writing it like this. Okay? So that's how I show, the slide before is how we show multiplication. If I was dividing by x, I'd put it over x. So it's just kind of retraining your minds into thinking about what's going to be easiest to use, and you're just setting yourselves up for later to make it easier to understand. The quicker you get, you got to let some of your old habits die. Okay? And just kind of replace those thoughts with some fresh ones. Try number 5. 3/4 more than a number equals 16 3/4. This is just more than. We're not talking multiplication here. All right, 3/4 more than a number Like we said yesterday, you break it up a little bit. And you see terms like more than. What do you think of? Adding, right? And when you see this phrase, you're going to see it a lot. A number. That's a variable, because if they knew what the number was, they would just tell you. So a number is usually where we're going to put our variable. But that's just where we put it here. Doesn't mean that it's going to automatically be 3/4 plus x. It just means that in my statement, this is what represents the variable. So following the pattern that we've been following, how am I going to show 3/4 more than x? Awesome. X plus 3/4 equals 16 and 3/4. Very good. I can only say that I have 3/4 more than if I know how much I have. I can only say that it's 3/4 more than x once I know what x is. Kind of like Zakai's shoes again. Yeah. No. Can't. Can't switch them up. Look at the worksheet. Look at all the 18 problems that we went through today. We followed a consistent pattern. When we saw more than a number, we did them a certain way. That doesn't change, okay? Doesn't change. All right, here's what we're going to do. Flip over your worksheet. How many problems did I give you yesterday? 2? All right, so we're going to do all 10 today. All right, we're going to write as an equation. So like number 1 says 5 times a number equals 75. Okay, so here's a line. How are we going to show 5 times a number equals 75? Casimir. Five x equals 75. Is she correct? Absolutely. Very good. Do you want to use something else for x? You want to use a different letter? Go ahead. It's up to you. You have 26 to choose from. So if you want to use K for Casimir for every single one, go for it. If you're Casimir, you might want to use C. That's okay. Okay? So 1 through 10, and number 1 is done for you already.